The next inference I want to talk about is what I like to think of as interchangeable groups. And this is actually something we've seen in at least one other game so far if you've been following along in the lessons. But I wanted to talk about it specifically and isolate it just because it's so important to recognize it when you can. So let's see how it comes up in this game. We have 7 kids, JKL, M, O, P, and Q, attending a summer camp. During one afternoon, the kids are divided into 3 different groups: the red group, green group, and blue group. So it seems like we have 3 groups: red, green, blue. Each kid is assigned exactly once, and every group has to have at least one of the kids. So based on that setup, your initial instinct should be something like this, I think. Here are the 3 groups, RGB. They all have at least one kid, so they all get at least one slot, and these 7 people are going to be assigned. So now let's quickly go through these basic rules. M and P are assigned to the same group, so that's going to look like this. They have to go horizontally together. Q and J cannot be assigned to the same group, so that's going to look like this. You can never put them horizontally in the same group. And then the final rule is no other kid is assigned to the group to which K is assigned. So in other words, wherever K goes, K has to be alone. And let's make sure to note that L and O are free agents. There's no rules about them. Now at this point, if your instinct is just to move on to the questions, you're missing out on a really important opportunity here, and that relates to the fact that there's no rules that are specific to these groups. Even though we are calling the groups red, green, and blue, none of the rules treat these groups differently. You don't have any rule that says, like, if M is in the red group, then someone else also has to be with them in the red group. You don't have any rules saying that a green group is limited to only one. And so if none of your rules and none of the constraints in the game are specific to an individual group, that's when you can think of the groups as interchangeable. And instead of actually writing RGB like this, we can and should actually just remove these group labels, because that allows us to realize that we can just start putting in some of these rules directly into the diagram. You see, the problem is if you leave these labels on like this, you might be very hesitant about putting MP in these groups. You might think, okay, well, MP could go in red, they could go in green, they could go in blue. That's 3 different worlds. But actually what's happening here is these group labels don't matter, and you can and should just throw MP into a group like this. This group that MP is in is either red or green or blue. And so now you're done with rule number 1. And you also know that K has to be alone, and so let me just actually put K alone. We know a K is going to be in a group of some kind. Let's just put it there. This one is going to be sealed off because no one else can go with K. And so now you're done with rule 3. And now Q and J, we know they can't go together. There's only 2 open groups left, so that would mean one of Q or J has to go here, the other of Q or J has to go here. And so now you're done with rule 2. Now at this point, any one of these groups could be red, green, or blue, and so if a question just happens to specify, for example, if M is in the blue group, well then for that particular problem you would just think of this group as the blue group, and these other 2 could be interchangeable between red and green. So that's the power of recognizing interchangeable groups. It allows you to realize that you can and should start putting at least some of your rules directly into the diagram. If you didn't realize the interchangeability of the groups and you just stuck with a setup like this, then the game would seem like it has a lot more options than it really does.